So far, all the code we've written has been executed sequentially, one after the other, with every line being executed. This doesn't have to be the case, and using control flow statements, we can alter the path of execution. There are many ways we can do this, so let's go over each one. A loop is one of the more common constructs used in programming languages. We use loops when we want to repeat a certain set of actions, or a block of code, more than once. Now I'm going to use my son as an example here. He's 2 years old right now and has a bunch of Lego bricks. When he plays with them, he dumps them all over the floor. When it's time to clean up the bricks, if I tell him, pick up the bricks, he'll only pick up one. Typical toddler. They function more or less like computers, and you have to be really explicit. To get him to finish the job, I'd have to say, pick up the bricks until there are no more left on the floor. Now this is essentially how a loop works. You have a set of actions, here it's pick up the bricks, and then a condition for when you want to stop the loop. The condition I give my son is when there are no more left on the floor. Let's look at a similar example in code.
In the last set of videos, we learned about two collection types, arrays and dictionaries. In the case of the array, we used a hypothetical to-do list to illustrate our example. Using indexes, we retrieved each task but could only do that one at a time. What if you wanted to go through the entire list and do something with each item? Let's add a new page to our playground, and we do this by clicking on the first icon in the second set of 3 to hide or show the project navigator. At the bottom on the left-hand side, there's a plus button. Click that to add a new page. We'll call this new page Control Flow, and we'll rename the first one by hitting Enter, and we'll call it Collections. Let's get rid of all the code in here and recreate our array from the previous videos. So we're going to create our to-do list, which was a variable to-do list, var to-do. Now, for the sake of practicing, let's write out the type explicitly. So we put a colon, space, and since this is an array of strings, we use 2 box brackets and the type string in between. To this variable, we're going to assign our collection. Now we want to create an array, which we start with an open brace, and then in here we put a series of string literals, or any value, and then separate each one with a comma. So the first one is finish collections course. The second, buy groceries. Next, we have respond to emails. After that, we'll add pick up dry cleaning. Couple more, order books online. And then for the last one, we'll say mow the lawn. Okay, now let's say I wanted to access each item in this array and print it out. Now we haven't looked at how to print something, and by print I don't mean print on a piece of paper. What I mean is we want to display something in this console area. So right now, anything that is evaluated is displayed here in the results area, but using a print statement, we can actually get it to show in here. And if you don't see this console area, it is the second icon in the set of 3 to bring it up. Swift has a function called print. So if you start typing print, it should autocomplete. And when you hit enter, we give it something to print within these parentheses. Now this is called a function, but we don't have to worry about it right now. We'll find out soon enough what a function is. So whatever we put inside these parentheses is displayed in the console. Now, when I mean whatever, I mean valid code. So if you wanted to print your name, you can't just write your name in here because this isn't valid code. When I put my name in here, the compiler, Swift, thinks I'm referring to some constant or variable named Passan. To actually print this, we need to make a string, so I need to surround it in double quotes. Now, to print the first item in the array, we can do it 2 ways. We can first read that first value in the array and assign it to some constant. So we could say let first item equal, and remember to access something in the array, we start with the name of the array, and then using subscript notation, we pass in an index. So now the first item in the array is assigned to the first item constant. Now to print this out, we simply pass in that constant to the print function or the print command. And now you'll see in the console area, that first item finished collections course is displayed right there. But we don't need to do this. We don't need to go through the process of reading from the array and then assigning it to a constant and then using that to print. Instead, all first item is this expression, is this command that we wrote. So we can simply get rid of first item and put the command itself in there. Okay, now it'll do the same thing because essentially this is the same thing. Now if assigning it to a constant and then printing it is easier for you to kind of understand, you can go ahead and do that. Okay, so over here in this exercise, we want to print out every item in the array. We've managed to print out the first item. How would we print out the second? So we'd write print again, hit enter, and then we'd get the second item from the array using the index number 1. Okay, so far so good. You can see buy groceries printed. Well, what about the third one? So again, we'll type print, hit enter, type to do, open square brace 2, close brace, and then close the parentheses. We can do this over and over again until we've printed out all the items in the array. This is cumbersome, however, and if we had an array with 1,000 items, that's a lot of code to write. In fact, there are several drawbacks. We're leaving a lot of room for errors in the form of typos. And we need to know how many print statements we need to write because, remember, an index out of bounds causes an error.
So let's solve this problem by using a loop. The first loop we're going to look at is called a for loop. The syntax for a for loop looks like this. We start with the keyword for, followed by a name that we're going to give to every single item in the array, name. I'll explain what this name is in a second. Then we use the keyword in, followed by the name of the array that we want to iterate over. Finally, we place a set of curly braces. The line of code starting from for and ending in the name of the array sets up the loop. The section between the braces is known as the body of the loop. Inside the body of the loop, we can add any amount of code we want. What kind of code? It's any code that we want to apply to each item in the array. Let's go back to the example with my son and his blocks. I'm going to stretch this example a bit, but bear with me. Perhaps it will help you better visualize the workings of a for loop. If we think of the pile of bricks as our source, the data we want to iterate over, let's arrange them neatly in order. This sort of resembles how data is stored in an array, right? Now, let's go back to that task where I asked my son to get those bricks off the floor and into a bin. Remember, my son needs explicit directions. He also loves to name things. Without a name, he's not going to work with it. So he picks up a brick and calls it something. Let's say, for the sake of this example, he calls it brick. Nice and simple. I then tell him to put brick in the bin. He then picks up the next brick, calls it brick, and looks at me for instructions. Again, I say put the brick in the bin. We keep doing this until he's gone through all the bricks in the list. This is exactly how a for loop works. My son here represents the for loop. He works with a data source, in this case, a series of bricks. We give each item a name in a for loop when we pull it out of the data source. Here he calls each brick, brick. Once an item is pulled out of the data source and given a name, we do some work with it. The key point to remember is that we do the exact same thing with each item. My son, or the for loop, continues until there's no more bricks in the pile or no more items in the data source.
So let's try this in code. Let's get rid of these 3 print statements that we wrote, and instead we'll write a for loop. Now again, if I haven't explained this, the reason we call it a loop is because it does something over and over. So you can imagine in your head like a circular motion. It goes in a loop over and over doing the same thing until it's done that same thing to every item in the collection. So to create a for loop, we first start with the keyword for. Now the purpose of the for loop is to pull each item out of the collection and do something with it. And because we're pulling something out and using it temporarily, we want to assign that value to a constant and give it a name. So we say for task. Now this over here, remember when we started out, we did let first item equal to do 0, right? You remember this? Now what if instead I name this item? Let item equal to do 0. So over here I have the first item. Well, when I want the second item, I can just get rid of 0 and put 1. Now the second item is assigned to item. Now instead of item, what if we call this task and then work through the numbers until we've got them all? That's exactly what we're doing here. So we're taking each item out of the array and we're assigning it to a constant called task. All you have to do here is Swift does not make you write for let constant equals and then pull it out of the array. You just have a short form to refer to it. So you just give it a name and say every item that's pulled out of an array is going to be assigned to this constant called task, right? So that's what task is. So for task, the next is in, and then we specify the collection we want to work with. So we'll say to do. Okay, so this is the body of the for loop. Inside the body of the for loop, anything we put in here is applied to each item in the array that we can refer to using the constant task. All we want to do is print it. So we'll say print task. If you look in the results area, it says the print code was executed 6 times. And if you look in the console, you'll see that every single item is printed out on a separate line. So what just happened? A for in loop can be broken down into a distinct set of steps. It might be easy for you to understand what's going on, but let's break it down anyway. First, the loop checks how many items there are in the array. It can do this by checking the count property. In the case of to do, that returns 6. Then we create a variable called I, which is short for index, and we set it to 0. Using this index value of 0, we retrieve the first element in the array and assign it to a constant. In our case, the constant is named task. Then, inside the body of the loop, we do whatever we want with that constant task which contains the item. And in our case, we simply print it. Once all the code in the body of the loop is executed, we go back to the top, add 1 to the variable, and start over. So with I equal 1, we use this value as an index now to get the second item in the array. And again, we assign it to a constant named task. We do this over and over until we reach the end. We keep doing this until the value of I is 1 less than the number of items in the array, which, if you remember, we got by using the count method. So every time at the end of the loop body, the compiler asks, is this the end of the loop? As in, is I 1 less than the value returned by the count method? If not, execute the loop again. If yes, stop. This is all done for you in the background by using a for in loop. And if you'll notice, it uses concepts that we're familiar with. It uses different operators and constants to do all this work. This is called an abstraction. So over here, we don't have to worry about all those nitty-gritty details. We have some nice simplified syntax for task in to do that carries out all this work for us in the background. Essentially, we've abstracted away all the details. Pretty neat, huh?
Iterating over an array and executing some code on each item in the array, the action we just undertook, is the most common use for a for loop. This process is also called looping over an array. But there's one more common use for it, and it involves an operator we haven't seen before. Let's look at that in the next video.